Okay, so subject name is strength of materials. The chapter name is simple stresses and strains. Okay, so first of all, so what is the use of subject? Okay, so let us see. So the strength of material is a subject. Okay, so the branch of engineering science which deals with the ability of various types of materials to resist its failure and their behavior under the action of the forces. Okay, so that is the use of strength of material subject. Okay, so in this subject, so we can learn so all these things. So first one is stress. That means what is the meaning of stress, then what is the meaning of strain, then next one is types of stresses, then types of strains, then Hooke's law, then modulus of elasticity, then modulus of rigidity, then Poisson's ratio, then lateral strain, then longitudinal strain. Then next one is the thermal stresses. Okay, so that means a definition of thermal stresses and their problems. Okay, so then next one is analysis of bars and problems. Okay, then tapering, circular rod, then rectangular, so bar. Then next one is a composite bar and their problems. Then next one is Buck modulus. Okay, then volumetric strain, then properties of materials, then stress strain curve. Okay, so these are the very important. Okay, so in this chapter, then so first one is stress. Okay, so what is the definition of stress? Okay, so the stress, it is defined as the internal resistance force per unit area is known as stress. Okay, so what is the definition of stress? It is defined as the internal resistance force per unit area. Unit area is called stress. Okay, so what is the definition of stress? The internal resistance force per unit area is called stress. So it is denoted by sigma, then sigma equal to P by A. So P means the internal resistance force, that means force, load, so A means area. Okay, so this is the mathematical formula. So units for stress. Okay, so then P means load, so load units are newtons by. The next one is A, so area, so area units are meter square. Okay, then R, so then Newton for mm square, so R, then Newton for centimeter square. So these are the units of stress. Okay, so what is the definition of stress? The internal resistance force per unit area is called stress. Then it is denoted by sigma, then sigma equal to P by A. P is the internal resistance force. Okay, then A is the unit area, that means area of cross section. Then next units are Newton for meter square, or Newton for mm square, or Newton for centimeter square. Okay, so Newton is the force unit, meter square or mm square or centimeter square is centimeter square. So the unit of area. Some relations are very important. Okay, so the next one is 1 kilo. So 1 kilo means 10 power of 3. So it is denoted by capital K. The next one is 1 mega. So mega means 10 power of 6. So it is denoted by capital M. So 1 giga. So giga means 10 power of 9. It is denoted by capital G. The next one is 1 tera. So 1 tera means 10 power of 12. It is denoted by capital T. So these are the very important for solving the problems. Okay, so kilo means 10 power of 3, mega means 10 power of 6, giga means 10 power of 9, then tera means 10 power of 12. So next one is types of stresses and strains. Okay, so types of stresses and strains are divided into 3 types. Then first one is tensile stress, second one is compressive stress, third one is shear stress. Okay, so for strains, tensile strain, compressive strain, the next one is shear strain. Okay, so first one is a tensile stress. So what is the meaning of tensile stress? That means what is the definition of tensile stress? Okay, so when a body is subjected to equal and opposite forces pulls the body as a result of which the body tends to extends its length and area decreases. Okay, so let us consider one body. So two equal and opposite is the P force. Okay, then so pulls the body, then the body tends to increase in length, and so next one is the area is decreases. Okay, so let us take one rubber elastic. Okay, just two equal and opposite forces acting on elastic. Okay, so then the elastic length is increases, the area is decreases. Okay, so then next, so let us consider a bar subjected to a tensile force P at its ends. Okay, the force P acting at the end of bar. Okay, so consider section XX, which divides the bar into two parts. Okay, so the part left of the section XX will be in equilibrium if so then P equal to R. Okay, the next one is second one. Okay, the part right to the section X, then X, so will be equilibrium. Okay, so if P equal to R, so R means a resisting force, so P means that means applying force. Okay, so these two are so equilibrium in left hand position, then equilibrium right section. Okay, so that means equilibrium means then P equal to so acting load equal to resisting load, then acting load equal to resisting load. Okay, so finally, so this is the final diagram. The next one is tensile stress, means the resisting force or resisting load by area, then resisting load equal to P, then area equal to A. Okay, so this is the mathematical formula of tensile stress. Next, tensile strain. Okay, so tensile strain means so delta L by L. So this is the mathematical formula. Okay, so delta L means change in length by L means original length. Okay, so this is the mathematical formula of tensile strain. So how to define tensile strain from this mathematical formula? Okay, so delta L by L, so by means ratio. Okay, the ratio between so change in length to the so original length is known as tensile strain. Okay, so change in length means so increase in length by so original length is known as tensile strain. So increase in length by so original length. Okay, so is known as tensile strain. Okay, so this is the definition of tensile strain. Okay, so for tensile strain there is no units, so because of this is the delta L. So delta L means change in length. The next one is L, length, so length by length, so cancel. Okay, so the next one is so for tensile strain no units for tensile strain. Next one is second one is compressive stress. Okay, so definition of compressive stress is two equal and opposite forces so push the body, as a result of which the body tends to decrease its length and increasing the area. Okay, so let us consider one body. So this is the body. Okay, so then push the body. Okay, so in this case just push the body. So in this case the length is decreases, that area is increases. Okay, so area is increases, length is decreases, then area is increases. Okay, so it is denoted by sigma c, then sigma c equal to then resistance force per unit area, then resistance force means push force, so both are equilibrium. Then next one is equal to area, A equal to area, then equal to P by J. Okay, then so finally sigma c equal to so P by A, so load per unit area. Okay, so but what is the difference between compressive stress and tensile stress? In tensile stress, the load is pulling. In compressive stress, the load is pushing. Okay, then in compressive stress, the length is decreases. In tensile stress, the length is increases. Okay, next one is a compressive strain. Okay, so what is the definition of compressive strain? Okay, so this is the general mathematical relations. E equal to delta L by L. Okay, so E equal to delta L by L. Okay, so delta L means change in length, L means original length. So what is the definition of compressive strain? Okay, it's the ratio between change in length to the original length is known as compressive strain. Okay, so change in length means decrease in length. Okay, so original length means L. Okay, so what is the definition of compressive strain? Okay, the ratio between decrease in length to the original length is known as compressive strain. So it is denoted by E. Okay, so no units for strains. Next one is shear stress. Okay, so what is the definition of shear stress? The stress induced in a body, okay, so when subjected to two equal and opposite forces which are acting tangentially across the resisting section, so then as a result of which the body tends to shear off, okay, across the section is known as shear stress. Okay, so these are two diagrams. Okay, then this is the shearing section. Okay, the next one is, so it is denoted by tau. Okay, so this is the symbol of shear stress. Then shear stress equal to P by A, that means load by area. Okay, so tangential force per unit area. Okay, the next one is shear strain. The corresponding strain is known as shear strain. Okay, so this is the symbol of shear strain. Okay, then shear stress equal to tau equal to P by J. Okay, so units are Newton for meter square, or Newton for mm square, or Newton for centimeter square. Then this is the pi. Okay, so symbol of shear strain. So types of stresses and types of strains is over. Okay, so the next one is Hooke's law. So what is the Hooke's law? The stress is directly proportional to the strain. Okay, so that is known as Hooke's law. Okay, so what is the definition of Hooke's law? The stress is directly proportional to the strain is known as Hooke's law. Okay, so then sigma equal to E into small e, then E equal to sigma by E. Okay, so this is the relation between Young's modulus, then next one is stress and strain. Okay, so this is the definition of Hooke's law. Then next one is volumetric strain. So volumetric strain, it is denoted by E suffix V. So V means volumetric, E means strain. So volumetric strain. So next EV equal to, this is the mathematical formula, then EV equal to delta V by V. So delta V means change of volume, then V equal to original volume. Okay, so volumetric strain means the ratio between change of volume to the original volume is known as volumetric strain. It is denoted by E suffix V. Okay, so what are the units for volumetric strain? So no units for volumetric strain. So this is the volume, change of volume. So this one also volume. Okay, so in case of, let us take one example, EV equal to delta V by V. So delta V, change of volume, so then meter cube, then volume, then meter cube, then meter cube cancel. Okay, so that no units for volumetric strain. The next topic is modulus of elasticity. Then modulus of elasticity, that means Young's modulus. Okay, so capital E. So capital E equal to sigma by E. So this is the mathematical formula of modulus of elasticity or Young's modulus. Okay, then E equal to sigma by E. So what is the definition of modulus of elasticity or Young's modulus? The ratio between stress to the strain is known as modulus of elasticity. then E equal to sigma by E. Then next units, so what are the units for Young's modulus? So Newton for meter square, or so Newton for mm square. Okay, so Newton for meter square or Newton for mm square. So these are two so units for modulus of elasticity. The next, modulus of rigidity. Okay, C or N or G. So these are the three symbols, okay, so represent the modulus of rigidity. Then modulus of rigidity equal to so tau by pi. So the next, tau means shear stress. The next, pi means shear strain. Okay, so what is the meaning of tau? Shear stress. What is the meaning of pi? Shear strain. So please define the modulus of rigidity. Okay, so it is defined as the ratio between shear stress to the shear strain is known as modulus of rigidity. Okay, so next definition is factor of safety. So factor of safety means so the ratio between ultimate stress to the permissible stress or design stress is known as factor of safety. So next definition is Buck modulus. Okay, so it is defined as the ratio between direct stress to the volumetric strain is known as Buck modulus. So Buck modulus, it is denoted by K. So K equal to sigma by EV. So this is the mathematical formula. Then sigma means direct stress or stress, EV means volumetric strain. Okay, so this is the definition of Buck modulus. The next one is Poisson's ratio. Okay, so define Poisson's ratio. So how to define the Poisson's ratio? The ratio between lateral strain to the longitudinal strain so is known as Poisson's ratio. So Poisson's ratio, it is denoted by mu or so 1 by m, then equal to lateral strain. Okay, so lateral strain means delta so B by B or delta T by T by longitudinal strain is delta L by L. Okay, so this is the definition of Poisson's ratio. First one is Hooke's law. Then the stress is directly proportional to strain, volumetric strain, the ratio between change of volume to the original volume. Okay, so no units for volumetric strain, modulus of elasticity, then E equal to sigma by E. That means the ratio between stress to the strain is known as modulus of elasticity or Young's modulus. So units of modulus of elasticity is Newton for meter square or Newton for mm square. Then modulus of rigidity, so it is denoted by C or N or G, so equal to tau by pi. So tau means shear stress, pi means shear strain. Okay, the ratio between shear stress to the shear strain is known as modulus of rigidity. The next definition is factor of safety. Then it is defined as the ratio between ultimate stress to the permissible stress is known as factor of safety. So no units for factor of safety. Then Buck modulus. Then Buck modulus K equal to sigma by EV. Then sigma means direct stress, EV means volumetric strain. The definition is the ratio between direct stress to the volumetric strain. Then next, already you know the Poisson's ratio, lateral strain by longitudinal strain. So the Poisson's ratio, it is denoted by mu or 1 by m. Okay, then equal to lateral strain means formulas delta B by, that means change of width by original width, change of thickness by original thickness, by longitudinal strain means delta L by L. So these are the mathematical relation and definition of definitions. So these relations are very, very important. Then capital E means Young's modulus, G means modulus of rigidity, K means Buck modulus, mu means Poisson's ratio. Okay, so first one is E equal to 3k into 1 minus 2 mu. Okay, so this formula is used for calculation of K or calculation of E. Okay, then next one is E equal to 3k into 1 minus 2 mu, then K equal to E by 3 into 1 minus 2 mu. Okay, so this formula is a relation between the E and K. Okay, then next formula is relation between E and G. So E means Young's modulus, then next one is G means modulus of rigidity, then E equal to, so 2G into 1 plus mu means Poisson's ratio. Then third formula is the combination, that means the relation between E and K and G, Buck modulus, then Young's modulus, modulus of rigidity, then E equal to 9 kg by 3k plus G. So fourth formula is the relation between mu kg, then mu equal to 3k minus 2g by 6k plus 2g. So these are the very important for solving the problems and for competitive exams. Next, so explain two problems. These two problems are related to so previous topics. Okay, so next one is, so one rod, so 140 centimeters long of diameter 2 centimeter is subjected to an axial pull of 25 kilonewton if the modulus of elasticity of the material of the rod is 2 into 10 power of 5 Newton per mm square. So just determine stress, then strain and elongation of rod. So first one is the rod 140 centimeter long. Okay, then long means a length, so then L equal to 140 centimeters. Okay, then next one diameter. So diameter indicates small d, then 2 centimeters, then is subjected to an axial pull of 25 kilonewton. So 25 kilonewton, that means force. 25 kilonewton is force. So 25 into 10 power of 3 newtons. If the modulus of elasticity of the rod, so modulus of elasticity, that means it is denoted by E, so 2 into 10 power of 5 Newton per mm square. Okay, so just determine A, stress. Determine A, stress equal to question mark. So L means length, D means diameter, P means load, then next E means Young's modulus. Just calculate the stress. Okay, so already you know the stress, then stress equal to, so load by area. Okay, so before solving the problem, so very important is unit conversions. Okay, so length in centimeter, D diameter in centimeter, then E Young's modulus in terms of mm. Okay, so this is centimeter, this one is mm. Okay, so just convert into, so centimeter into mm, or so these mm into centimeters. Okay, just convert into, so all are in one form only. So whenever solving the problem, so unit conversion is very important. Okay, then